After watching this video, you'll be able to recognize the importance of embracing failure, explain the importance of quick recovery from failure, describe how retry patterns, circuit breaker patterns, and bulkhead patterns help make applications resistant to failure, and describe chaos engineering. Once you design your application as a collection of stateless microservices, there are a lot of moving parts, which means there's a lot that can go wrong. Services will occasionally be slow to respond or even have outages, so you can't always rely on them being available when you need them. Hopefully these incidents are very short-lived, but you don't want your application failing just because a dependent service is running slow or there's a lot of network latency on a particular day. This is why you need to design for failure at the application level. Since failure is inevitable, you must build your software to be resistant to failure and scale horizontally. We must design for failure. We must embrace failure. Failure is the only constant. We must change our thinking from moving to how to avoid failure to how to identify failure when it happens and what to do to recover from it. This is one of the reasons why we move DevOps measurements from mean time to failure to mean time to recovery. It's not about trying not to fail. It's about making sure that when failure happens, and it will, you can recover quickly. Application failure is no longer purely an operational concern. It's a development concern as well. For the application to be resistant or resilient, developers need to build that resilience right in from the start. And because microservices are always making external calls to services that you don't control, these services become especially prone to problems. Plan to be throttled. You're going to pay for a certain level of quality of service from your backing services in the cloud, and they will hold you to that agreement. Let's say you pick a plan that allows 20 database reads per second. When you exceed that limit, the service is going to throttle you. You're going to get a 429 too-many requests error instead of a 200 OK, and you need to handle that. In the case you would retry, right, in this case, this logic needs to be in your application code. When you retry, you want to back off exponentially when it fails. The idea is to degrade gracefully. If you can, cache where appropriate so that you don't always have to make these remote calls to these services if the answer is not going to change. Now, there are a number of patterns that are important strategies, very important strategies to help you make applications resilient. I just want to go over a few of the popular ones. The first one is the retry pattern. This enables an application to handle transient failures when it tries to connect to a service or a network resource by transparently retrying and failing the operation. I've heard developers say, you must deploy the database before you start my service, right? Because it expects the database to be there when it starts. That is a fragile design, which isn't appropriate for cloud-native applications. If the database is not there, your application should wait patiently and then retry again. You must be able to connect and reconnect and fail to connect and connect again. That is how you design robust cloud-native microservices. The key here is the retry pattern, to back off exponentially and delay longer in between each try. So instead of trying like 10 times in a row and overwhelming the service, you retry, it fails. And you wait a second, you retry again. Then you wait 2 seconds. Then you wait 4 seconds. Then you wait 8 seconds. Each time you retry, you increase the wait time by some factor until all the retries have been exhausted, and then you return an error condition. This gives the backend service time to recover from whatever's causing the failure. It could be just a temporary network latency. The circuit breaker pattern is similar to the electrical circuit breakers in your home. You've probably experienced circuit breaker tripping in your house. You may have done something that exceeds the power limit of the circuit, and it causes the lights to go out. That's when you go down to the basement with a flashlight, right? And you reset the circuit breaker to turn the lights back on. Well, the circuit breaker pattern works in the same way. It's used to identify a problem and then do something about it to avoid cascading failures. A cascading failure is when one service is not available and it causes a cascade of other services to fail. With the circuit breaker pattern, you can avoid this by tripping the breaker and having an alternate path return something useful until the original service recovers and the breaker closes again. The way it works is that everything flows normally as long as the circuit breaker is closed. The circuit breaker is monitoring for failure up to a certain limit. Once it reaches that limit threshold, right, that certain threshold, the circuit breaker trips open and all further calls to the circuit breaker return with an error, without even calling the protected service. And then after a timeout, it enters this half-open state where it tries to communicate with the service again. If it fails, it goes right back to open. But if it succeeds, it becomes fully closed again. The bulkhead pattern can be used to isolate failing services to limit the scope of a failure. This is a pattern where using separate thread pools can help to recover from a failed database connection by directing traffic to an alternate thread pool that's still active. Its name comes from the bulkhead design on a ship. Compartments that are below the waterline have walls called bulkheads between them, and if the hull is breached, only one compartment will fill with water. The bulkhead stops the water from affecting the other components, the other compartments, right, and sinking the ship. So using a bulkhead pattern isolates the consumers from the services as cascading failures by allowing them to preserve some functionality in the event of a service failure. Other services and features of the application continue to work. Finally, there's chaos engineering, otherwise known as monkey testing. While not a software design pattern, it's a good practice to prove that all your design patterns work as expected under failure. In chaos engineering, you deliberately kill services to see how other services are affected. Netflix has a suite of failure-inducing tools called the Simian Army. Chaos Monkey solely handles termination of random instances, and Netflix randomly kills things to see if they come up and whether the system will recover gracefully. You cannot know how something will respond in a failure in production until it actually fails in production, so Netflix does this on purpose. All of these patterns can help you build more robust software and respond gracefully to intermittent failures. In this video, you learn that failure is inevitable, so we design for failure rather than trying to avoid failure. Developers need to build in resilience to be able to recover quickly. Retry patterns work by retrying failed operations. Circuit breaker patterns are designed to avoid cascading failures. Bulkhead patterns can be used to isolate failing services. And chaos engineering is deliberately causing services to fail to see how other services are affected.